Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video on synthetic division. So synthetic division is essentially following the same steps as polynomial long division when we're dividing by a linear factor. It's just that it's written in a way that people usually understand better. So you'll be able to pick your favorite out of this and polynomial long division when dividing polynomials. Let's start with a question. So here we have a degree 4 polynomial divided by a linear factor. So what we do to do synthetic division is we just write the coefficients of our original degree 4 polynomial. So those coefficients, 1 minus 3, 4 minus 7, 1. 5 coefficients means it's a degree 4 polynomial. Now what we do is we look at the root of our linear factor here, x minus 2. What's the value of x that would make this equal 0? And that's of course positive 2. So we put the positive 2 down here. Alright, so let's start. So what we do is we start by bringing down this coefficient here, 1. Okay, so what we've discovered so far is that when I multiply x minus 2 by some polynomial to get this, it will have to be monic. Its leading coefficient has to be 1. We already knew that. We're going to multiply x minus 2 by x cubed plus blah, blah, blah. That's what we're going to do. I don't have to write what is in yellow at the moment. I'm just writing it to show you where we're going with this. So we know we're going to multiply our linear factor by some cubic. So when I do the expansion, I'm going to end up multiplying minus 2 by x cubed. So what I'm going to do now as my next step is I'm going to times positive 2 by 1, and that gives me positive 2. So I'm going to write my positive 2 here. So note that's sort of the negative of what's going to happen when I multiply minus 2 by x cubed. Doing polynomial long division, at each step I subtract in order to find the remainder. But here I'm going to add because I'm not using minus 2, I'm not using the coefficient, I'm using its negative. So the negative of subtracting is like adding the negative. So I'm going to go minus 3 plus 2, which gives me minus 1. And that's the coefficient of the next term. So I put that minus 1 there so that when I do minus 2 times x cubed, that'll give me an x cubed term. I'll also get another x cubed term when I go x times minus x squared. So x times minus x squared minus 2 times x cubed will give me exactly minus 3x cubed, which is what I wanted here. So that's the process here of synthetic division. Just finding what are the coefficients we need so that we can get this polynomial here. So I do the same thing again. I go plus 2 times negative 1, and that gives me negative 2. So again, that's the negative of what I will get when I times minus 2 times negative x squared. So in order that I can get 4x squared, I need to again calculate the remainder. Once again, I'm adding here because I'm using 2 rather than negative 2. So 4 plus negative 2, of course, gives me positive 2. So 2 goes down there. Now I follow the same process again. So 2 will end up being the coefficient, the next coefficient in my polynomial. It'll be 2x. 2 times 2, I now multiply these together. 2 times 2 is 4. Put a 4 there, I add them and get minus 3. So a minus 3 is going to go here. So I've now found the polynomial that I want to multiply by my linear factor to get the degree 4 polynomial. The last thing I need to do is calculate the remainder. So I go 2 times minus 3, that gives me minus 6. And once again, I add 1 plus negative 6 gives me negative 5. So that's the remainder here. So I'm going to need to put a minus 5 on the end. Of course, this means x minus 2 isn't a factor. So I went through this slowly and tried to explain what's happening at each step for those that can understand. If you don't quite understand why synthetic division works, that's okay. In the next example, I'm going to go through it quicker, and I'm just going to go through the process. So if you don't understand why it works, just make sure you understand how it works, and you'll be able to use this instead of polynomial long division if you so wish. All right, please pause and copy this down if you need. So now I'm going to perform this division here using synthetic division. So as promised, I'm not going to go and try and explain why everything works. I'm just going to show you the process. So the process is we write the coefficients of the first polynomial. So it's 1x cubed plus 4x squared minus 2x minus 5. X plus 1, we take the root of that, the negative of that, so I put a minus 1 here. And I'm going to go through and find out the coefficients that I need. So I start by bringing the first coefficient down to get 1. Now I go minus 1 times 1 gives me minus 1. So I put a minus 1 here. Now once again, to calculate the remainder, I add 4 plus negative 1 gives me positive 3. So now I'm going to multiply negative 1 by 3. Of course, that gives me negative 3. Now again, I calculate the remainder. Minus 2 plus minus 3 gives me minus 5. Start the process again. Minus 1 times minus 5 gives me positive 5. Now minus 5 plus 5 this time is equal to 0. So remember, the last term here is my remainder. So I have a polynomial for which x plus 1 is a factor. So the answer is, I just get the coefficients from here. I know it's going to be a quadratic, a degree 2 polynomial. So it'll be x squared plus 3x minus 5. There is no remainder here because this last number was 0. So that's the remainder. This is the constant term. This is the coefficient of x and the coefficient of x squared. How easy is that? All right, I'm going to do one more example, and once again, I won't try to explain why it works. I'll just show you the process. So now we're going to use synthetic division on this example here. So I write the coefficients of the first polynomial. So it's x to the power of 4, 1x to the power of 4, no x to the power of 3, no x squared term, minus 1x plus 3. And again, I take the negative of my linear factor minus 4. So as I've done in the previous examples, I'm going to drop the first coefficient, bring it down, so that's 1. Minus 4 times 1 times those two together, I get minus 4. So I'll put that up here. Now I add for the remainder. 0 plus negative 4 is, of course, negative 4. Now I go minus 4 times negative 4, which is positive 16. So 16 goes up here. 0 plus 16 is 16. Start the process again. Minus 4 times 16 gives me minus 64. So I put that up here. Minus 1 plus minus 64 is, of course, minus 65. And I do it again. Minus 4 times minus 65 actually gives me a big number this time. It's going to give me positive 260, and 3 plus 260 gives me 263. So once again, this is the remainder. I've got 4 terms here, 4 coefficients, so it's going to be a cubic. This will be the coefficient of x cubed, coefficient of x squared, x, and the constant term. So what I've found out is that my original polynomial, x to the power of 4 minus x plus 3, is equal to x plus 4 multiplied by this polynomial here with these coefficients. So it's going to be x cubed minus 4x squared plus 16x minus 65, and there's a big remainder here, and that is plus 263. This time, x plus 4 was not a factor of the polynomial I started with. So hopefully you find this easier than polynomial long division. Thank you so much for watching. This has been the luckiest maths teacher in the world. Have a great day.